Today we're diving into a paper that explores a novel approach to improving the search capabilities of large language models, LLMs, for code generation. The paper, Planning in Natural Language Improves LLM Search for Code Generation, proposes a method called PLANSEARCH, which leverages natural language planning to enhance the diversity of generated code solutions. Let's start with the core problem this paper addresses. What are the limitations of current LLM search methods for code generation?
The primary challenge with existing LLM search methods for code generation is the lack of diversity in the generated solutions. LLMs often produce highly similar, yet incorrect, code outputs, leading to inefficient search. This is partly due to the training objectives that prioritize generating a single correct answer, rather than exploring a wider range of potential solutions.
So the paper argues that increasing diversity in the search space is crucial for better performance. How does PLANSEARCH address this issue?
PLANSEARCH introduces a novel search algorithm that focuses on exploring the space of natural language plans for solving a problem. Instead of directly searching over code solutions, it first generates a diverse set of observations about the problem in natural language. These observations are then combined into candidate plans, which are essentially high-level descriptions of how to solve the problem.
This sounds like a more abstract level of reasoning. Can you elaborate on how these natural language plans are used to generate code?
Once PLANSEARCH has generated a set of plans, it uses these plans as prompts for the LLM to generate code. The LLM is instructed to implement the plan, translating the natural language steps into actual code. This process is repeated for each plan, resulting in a diverse set of code solutions.
So PLANSEARCH essentially uses natural language as a bridge between the problem and the code generation process. What are the key benefits of this approach?
By searching over plans in natural language, PLANSEARCH explores a significantly more diverse range of potential solutions compared to baseline search methods. This increased diversity leads to a higher probability of finding a correct solution within a given number of attempts.
The paper mentions that PLANSEARCH outperforms both standard repeated sampling and a method called idea search. Can you explain the difference between these methods and why PLANSEARCH is more effective?
Idea search is a simpler approach that involves prompting the LLM to generate a natural language solution sketch before generating code. While idea search does improve diversity, PLANSEARCH goes a step further by generating a more structured set of observations and plans, leading to a more comprehensive exploration of the solution space.
The paper highlights the importance of diversity in the search space. How does the paper measure this diversity, and what are the findings?
The paper uses an LLM as a judge procedure to measure the diversity of generated code solutions. Two code samples are compared, and the LLM is asked to determine if they implement the same underlying idea. The diversity score is calculated based on the probability that two randomly selected code samples implement different ideas. The paper finds a strong positive correlation between this diversity score and the performance gains achieved by different search methods.
So the paper provides empirical evidence that increasing diversity in the idea space, as measured by the LLM as a judge procedure, leads to better search performance. What are the implications of this finding for future research in LLM code generation?
This finding suggests that future research should focus on developing training methods that explicitly encourage diversity in the LLM's output space. This could involve designing new training objectives that prioritize generating diverse solutions, rather than just a single correct answer.
The paper also mentions the potential for using PLANSEARCH to improve the performance of smaller LLMs. Can you elaborate on this?
The paper demonstrates that PLANSEARCH can be effectively used with smaller LLMs, achieving performance comparable to or even exceeding larger models without search. This suggests that search methods like PLANSEARCH can be a valuable tool for improving the efficiency of LLM code generation, especially when computational resources are limited.
The paper discusses the limitations of PLANSEARCH and potential areas for future work. What are some of these limitations and how can they be addressed?
One limitation of PLANSEARCH is that it currently searches all leaf nodes in the search tree uniformly. This can become computationally expensive as the search tree grows. Future work could explore more efficient search strategies, such as those based on Monte Carlo tree search, MCTS, to prune the search space and focus on promising branches.
The paper also mentions the potential for training LLMs on successful plans and code solutions obtained from PLANSEARCH. How could this approach further improve LLM code generation?
Training LLMs on successful plans and code solutions generated by PLANSEARCH could help to distill the knowledge gained from search into the model itself. This could lead to improved performance on code generation tasks, even without the need for explicit search at inference time.
The paper highlights the importance of filtering generated code solutions to improve performance. Can you explain how filtering works and its role in LLM code generation?
Filtering involves selecting the best code solutions from a pool of generated outputs. This can be done using various methods, such as public test filtering, where only code solutions that pass Bates's sanity checks are selected. Filtering can significantly improve performance by reducing the number of incorrect solutions that need to be evaluated.
The paper suggests that a new paradigm for LLM code generation could involve combining search methods that prioritize diversity with filtering techniques. What are the potential benefits of this approach?
This approach could lead to a more efficient and effective code generation process. By generating a diverse set of solutions and then filtering out the best ones, we can leverage the strengths of both search and filtering to achieve high-quality code outputs.
This was a fascinating discussion on the technical aspects of PLANSEARCH and its potential to improve LLM code generation. Thank you for sharing your insights.